anyone feels far away, just lie over here, and just like it'll help this like theatrical performance dynamic if we're closer. Like a three-dimensional wraparound out of stage wraparound.
No, it's room to eat.
Just kind of stay around. Just broke off the back. So how many people are here for the first time? Awesome. How many people? This is a logical problem. How many people are not here for the first time? I really didn't either. So there's a third. How many people are not fully listening yet? Oh yeah. The Erlang. Sorry, the Erlang. Chicago Erlang. Any meetup, not Braintree. Okay, cool. We've got I think great content, really interesting things. How many folks here are using Erlang in any way, like on a regular basis? Okay, that's great. And how many people are like sort of here, sort of wanting to get to know Erlang as an introduction? All right, great. So I think tonight's got both. I mean, really practical content. I know Reid's talk will have some really compelling information for people who don't know anything about Erlang and just are interested in it. It's like one of the most fantastic features of this platform. And Jesse's got things that are both interesting for folks who have been using it, and also like interesting things for those. So I think we've got a really interesting, good time tonight. So with that introduction,
All right, so this is going to be pretty short and informal, so feel free to shout out questions, tell me to speak louder or increase the font or whatever. How many of you have done any sort of tracing with Erlang before? A couple people? All right, so I'm going to show you what might be my favorite feature of Erlang. It's really kind of more a feature of the standard library and the virtual machine than the language itself. But it's the ability to trace and inspect a live running system. And for me, not only does this allow me to debug systems that are actually running in production or running on my laptop, for the most part, tracing has completely replaced a traditional debugger for me. I don't find the need to use a sort of stepwise debugger at all anymore. And I'm not sure if I'll necessarily be able to convince you that you'll be doing the same thing, but I think you'll see it's pretty powerful, and especially for production systems, you'll see people do some pretty cool things. So I've got a markdown file here that I will paste a gist of into the meetup links, so you can kind of follow along later, or if you want to follow along now, you can go clone this repository, which is where Redbug, which is a tool that we're going to be using, lives. So Erlang has a couple of different built-in tracing facilities. There are some built-in trace functions. There's DBG, which is a low-level module for tracing. The tool that I use for the most is called Redbug, just sort of a higher-level third-party tool that you can install. You just put this repository in your rebar config. So we'll play around with that. But the basic gist of what we're going to be able to do is we're going to actually be able to trace the execution of functions as they happen on a live running system. And to give you a sort of quick example, I've got two Erlang nodes that are both running here. So this is foo on top, bar on the bottom. They've already been connected to each other. And on this bottom one, I'm going to call the OS timestamp function. It's just a function call, right? And we get a result printed out. It's probably a little low on the screen, but you'll just have to trust me there. So what I'm going to do is start by actually tracing those function calls from the other node on the node that we just called the function on. So we're going to skip local tracing entirely and do something really cool, which is tracing the execution of a function on another node. So this could be our laptop and we're tracing on a production system. Or we could have 10 nodes in our production system and we're just logged onto one of them and starting to trace the execution on another node. So the tool we're going to use, the big font is causing this to kind of wrap around, but I'll go through this. We're going to call Redbug start. part. So this is the function with Redbug that you're going to use the most. We're tracing all calls to OS timestamp. If we wanted to, we could add an array in here. We could even do things like that, put guards in here so we can actually control when these traces get called. So we can only trace if we get called with false. So like, let's say we have this function that should only ever be called with true, but for some reason in production, we're pretty sure it's getting called with false. So we can set the trace up to only get triggered when the function gets called with false. One of the nice things, yeah.
What was the red button?
It's right here.
You bump up the font. Yeah.
How's that? I'll put this up online afterward too. This is just going to be a gist that's up. So one of the things you have to consider when you're tracing, especially a live production system, is you don't want your tracing to impact the actual running system. Like, you're usually tracing things when things are going wrong, so the last thing you want is your observation to make things worse. So Redbug has some really powerful tools for making sure that you don't shoot yourself in the foot as you do this. So there are sane defaults for a lot of these things, but we're going to explicitly say don't trace more than 10 invocations of this function, and don't trace for more than 10 seconds. And we're actually going to specify a different target node than the node we're on. And you can see if I actually, let's bump that down to 1 second. We'll see Redbug times out after a second. Let's bump that back up to 10. And on the other node, we'll call it OS timestamp. You can see here now, we're actually seeing the invocation of that function call on the other node. And we can see the arguments it's being called with, and since we've added this handy little return call right there, we can actually get the result of the invocation of the function. We can do cool things too, like say, give me the return value, and print out the stack as well. I'm actually,
Reid,
yeah.
it's really basic, but could you just like do a quick overview of nodes and why you're using two, like just really quick, distributed Erlang nodes?
Sure, yeah. So these are just two terminals, right? Okay, so on the top one, we're going to create one Erlang node, and PA just means path append, so we're just going to append to the path this ebin directory, which has some compiled bean files in it. I happen to be in the repository that I told you about, so I just cloned that repository. I typed make in there. The author was, I'll do it on the top window. The author was nice enough to provide a make file for us, but all it's probably doing is rebar compile or something like that. And then I am going into an Erlang REPL. I'm appending ebin, which has the code that we want to use, to the code path, and then I'm giving this node a name. So the short name is foo at. At just means use the host name to figure out what the full path should be. So if I do that, and now I type node, that just says, hey, what node am I? It says foo at Reid 11. And if you see host name, this is my laptop called Reid 11. And then in the other terminal, which, can you guys see that far on the bottom, or is that cut off too much? You can see it? Okay. So on the other one, instead of foo at, I'm just going to call it bar. And now, if I call a node on that one, now this is bar. So these nodes are not connected at all right now to each other. So if I type nodes, that gives a list of all of the nodes. They're not connected. But I can use this function called netadm, net administration, I think, ping, to ping the other node, which will connect these two nodes together. So I get back pong, and now if I type nodes, I see that I'm connected to that other node. Likewise, at the bottom, if I type nodes, I see them connected to foo. So these two machines can communicate using normal Erlang message passing semantics. And if you want to, you can be ignorant to whether you're communicating with a remote node or a process on your own virtual machine. Yeah.
So pinging does more than just, like what I would assume, just seeing if something's up. It actually initiates the ability to make communication between two nodes.
It does, yes, exactly.
Is that like the typical way that you would begin two nodes being connected by pinging the other one, and then you begin passing messages?
That's the most typical kind of low level that I'm aware of. There might be another way as well. I mean, oftentimes if you're writing distributed systems, you'll kind of use some other tool that kind of hides those details from you, and you'll connect the nodes and not actually be calling the low level functions like that and ping yourself.
Is R at Reid 11, does that get translated to like an ID? The Reid 11 gets translated to second?
Yeah, so there is another process that's running that is called EPMD, which is a operating system process that runs, that is the Erlang port mapper daemon, which if it's not running the first time you start an Erlang node, it'll automatically start it. And it's responsible for translating those friendly node names to IP addresses and ports. It's analogous to DNS, but for distributed Erlang. That all makes sense? Cool. So, yeah, let's see if I can get that stack. So we can actually see what the stack is if we add that stack call here. So I say not only do I want the return value, I want the stack at the time that this method's invoked as well. You can see it right here. We're in the shell loop. So that's not very helpful. You know, we know exactly what we're doing. But in the case that you're doing something like, hey, why is my module foo t when t equals true? Who is calling my module foo with true? We can actually do that on a remote node and get a message back with the stack and find out what code path is calling us like that. We can get the name of the process that's calling us like that, and we can do that on a remote node as well. There's a bunch of other more complicated things you can do. You can trace multiple functions. You can trace only processes that have a registered name. You can trace multiple nodes at once and aggregate the results. You can take the result and programmatically change it before you run it. So if you're getting called with a large data structure, then you can actually kind of pick it apart and only print to the console or to a file the part that's of interest to you. So there's a bunch of really cool things you can do. But the coolest thing for me is that you get to do all of this in production if you want. And let's take a look at our example here again. We'll bump time up to 20 seconds and messages down to 2. Now if we call OS timestamp a bunch of times, then it just quits because of the message count. So if you fat finger this and you accidentally start tracing a function that's called a few million times a second, it's not going to lock up your whole system. You can actually stop the tracing after you've only received 2 trace events, which allows you to kind of speculatively start tracing things without having to worry too much about causing more trouble than it's already happening. So that's a pretty good introduction. I can show you, some more examples, some actual things that I've traced before, but I think that's probably a pretty good start. You guys have any questions or anything in particular you want to see more? Yeah.
Does Redbug have to be a dependency on does it have to be on every node, or will Redbug be able to trace a remote node that doesn't necessarily have Redbug installed?
Yeah, I don't believe it has to be dependency, but let's try it. So this time we're going to start this bar node without the even directory. And we will ping foo again. Now we see that we're connected. We'll start Redbug.
What's this crazy shell you're using?
This is tmux.
No, the Erlang shell was it? Oh, you just have history within. Are you using a modifier?
Yeah,
shell?
I have Erl alias to Erl wrapped around it because I can't stand to not have reverse history search. I'm really lazy and I don't like to type, so.
So just Erl wrap, just you do an alias and.
Yep. RL wrap. It's it'll be on Linux probably if you have it. I think you can just brew install RL wrap if you're on a Mac. So yes, we can trace without Redbug installed. And that's because under the hood, Redbug is just using the built-in trace tools, which will be installed on the other node. So it's basically just a wrapper to compile this. So if you've noticed, this kind of looks almost like a function, definition right here, right?
Right.
Like, especially when we start doing things like m when m equals 5 and stuff. This actually gets compiled down to something called a match specification. And Redbug just has like a little parser that does a lot of that for you, so that you don't have to write that match specification for hand. There is some more power you can get if you use the kind of the lower level tracing stuff. And a few other people that I work with prefer using that or just have more experience. But for the most part, I've been really happy with using Redbug. And especially if you're using a live system, you have to be really careful about using the lower level trace stuff because you have to know the smart things that Redbug does to make the tracing not go crazy. So for me, Redbug is worked out really well. Anybody else?
What's the scenario for using this without distributed Erlang? You just have a node and.
Yeah, so I use it just like a debugger, actually. As far as I know, the only sort of traditional debugger for Erlang is a visual debugger. There's no kind of, if you've used Python, like PPD, is that what it is? The Python debugger, or GPD for C. There's nothing that I've seen that's really equivalent to a stepwise debugger like that. And for a lot of things, you don't even necessarily know what thread or process you want to be tracing on. And one of the cool things about Redbug and other tracing things is, you can trace this regardless of process. So if you have something that's concurrent that you're trying to debug, you're trying to figure out like which of my processes are calling this function with these arguments, and you can just start tracing anytime that function gets called on any process, or as we saw earlier, on any node too. So I use it for just like development, traditional kind of debugging stuff, in addition to just using the REPL, to test out functions myself. But I don't miss having a regular debugger at all.
When it installs a trace, and it says you do this 2 times, does it remove it after the 2, or is it just sort of in an idle state?
It removes it after the second time.
So it's clean after the second time.
Yep, so the lower level traces have a stop trace function, which I believe what it does, so you basically set yourself up to start receiving messages, just like normal or like message passing, and there's some accumulator in there that says, hey, I've gotten 2 messages now. Instead of going back and recurring to a receive loop, I should just call stop trace. Yeah.
Is there a Redbug command that will let you see all your current traces?
So Redbug only lets you have 1 trace at once. So here, let's try this. Let's start this trace, and then I'll try and start another one. It says Redbug already started. So when you start a trace, you can trace multiple functions. You can add multiple clauses. to trace different things, but once you press start, you can't trace again. However, there is a Redbug stop function. So if we, let's say that we set this time instead of 10 seconds to like 100 seconds, and we're like, oh man, I'm tracing the wrong function, I can just stop Redbug there, and now it will let me start again. Oh, something else that's important that I should mention is Redbug help. This is probably the best documentation there is for Redbug, which is kind of sad because this documentation is really dense. But yeah, think of this more as like a reference documentation than a tutorial. But just typing Redbug help in the console will give you some information as well. And if you Google around, you'll find Stack Overflow questions and stuff like that. But unfortunately, it is a little bit under-documented.
Find yourself ever needing to do IO format under these with Redbug? If you ever do that?
Yeah, I do sometimes. And a lot of the time.
You feel dirty doing that?
Yeah, I mean, not any more than any other language.
I did because tracing is so powerful. It's like if you have small functions, you shouldn't have to. But
yeah, I mean, admittedly, the time I end up doing it is when my functions are too big. When I can't just choose like, hey, just this one function call. So yes, I do occasionally do that, but it's usually like I feel a little bit bad about it, and it's usually a sign that I need to make things clear. But I'm definitely, of the opinion that do whatever works, and I use a lot of quick check, the tracing, and sometimes if just doing IO format feels like the right thing to do, then I just do it. Yeah.
I mentioned on your system Reid 11 is pointing to your local host.
Mm-hmm.
So is there significance to like even at put an IP? Does that mean you can go to a remote remote node that's running EMPD or
EMPD, yes.
Yeah. So you specify the IP, and it'll use that resolver to find the node for you.
Yes.
And then it provides the port and IP to get to that node.
Exactly.
So each node implicitly is going to open a port on the system it's running on.
Yeah, and you can have more than one Erlang node on one physical machine.
So yeah, for sure, yeah. And that's what the foo is. That identifies the specific
exactly.
node, right?
Exactly.
So there's significance to like foo at.
There is, yes. Exactly. Yeah, so under the hood that gets mapped to an IP address and a port.
Yeah, okay, cool.
So yeah, I mean,
yeah.
If we were using this with React, which is the product that we make at my company, it's a distributed database that's written in Erlang. You might have 50 machines that are each running React that are, potentially being run in different racks. If you're using the multi-data center stuff, maybe even different data centers. And once you've kind of had them do that ping step, they can all communicate with each other, and it's all sort of transparent to you. Cool. All right, anything else?
Could you go through a scenario where you just have this problem that couldn't be solved without this? I just think about like this in Java land, like
yeah, I mean
to debug production out problems is freaking impossible. It's like you've got to deploy these debug versions of software, bring the software down, bring it back up, and you're speculating constantly.
Yeah,
it's really expensive.
So when we do support for our customers, we will often just send them something to paste into a shell like this. So they might have, let's say they have a 10-node cluster. We'll say, hey, paste this snippet into a shell of one of those running Erlang processes. So if you don't know much about Erlang already, it's important to know that this REPL you can get can actually be gotten on a running node too. So it's not even just that, like in this case, there's no other Erlang that's running. This is just a REPL, just like if you typed Python or IRB or something. But you can actually get one of these REPLs to a running machine. That's a totally normal thing to do at Erlang. So you can get the REPL on a running machine and start running Redbug on there. So a lot of times what we'll do if we're not able to diagnose something immediately, is we'll send our customers a little snippet that they just paste into the shell and starts tracing to a file. This is all while the system is actually running. They haven't taken anything down yet. We'll go back and forth as long as we need to try and figure out what's going on. We will try and replicate the issue on our own local cluster, but the whole time that we're doing all this debugging, we can define new functions in here, we can trace all this stuff while the system is actually running, and then, if needed, send new code to the customer and have them load that code in, all without having to shut down any of the nodes. So it's like giving yourself a really, really powerful backdoor, which is the this is what I do a lot of my development in already. I know how to write Erlang code, so I have like the full power of my programming language to do my debugging in while the system is actually running, which I personally think is the coolest part about Erlang.
So you're using the term node, system, and machine. In terms of machine, you're talking about the virtual machine, the Erlang virtual machine. And so when you're connecting that with that shell, the REPL, you're connecting to the VM.
Yes.
And so the node, you're using the term Erlang VM and node synonymously, right?
I am in this case, yeah. Yeah,
So the system is composed of a collection of nodes to which you can attach.
exactly. In the case of our specific product, there's usually a one-to-one mapping between node and physical hardware, but that's just our own product. It doesn't have to be that way. Like we saw here, I can have two Erlang nodes, which means a virtual machine, on the same actual laptop here. I can have 100 of these on my laptop. Each one is using, let's see, one. So these top ones are other things that are running, but these bottom ones are just using a handful of megabytes of memory here. So the Erlang virtual machine is really lightweight. I can test and sort of replicate, at least in some ways, a 100-node system just on my laptop. But yeah, in the case of Erlang in particular, node means one virtual machine. Yeah.
This is your favorite aspect of the language. What's your second favorite?
I think that's a tougher question. So the reason it's my favorite is because there's really just nothing like it that I'm aware of in any other language. I've used a lot of other functional languages, so Erlang being functional while being really cool and powerful, other languages are functional languages too. The distributed system stuff is really nice, but that is something that theoretically can't be a library in another programming language. Other people write distributed systems in Java, and they work. It's not like Erlang gives us something that's impossible to do with Java as far as distributed systems.
Cost of isolation is small. Being able to architect your system around individual processes that are guaranteed to not blow up the entire system is a handy one. You see reliability differences if they actually show up. I think that's a material.
Yeah, that's fair. But yeah, so the reason that this is my favorite is because I just am not aware of anything else like it. And it sort of feels like a secret in the Erlang world. Like it's not really a sexy feature unless you've seen the pain that is trying to debug large, complex distributed systems before. If you don't even realize that that's a problem, then you don't know to look at that when you're looking at your program.
Any runs, those are going to be distributed.
Sure, yeah.
Like take down a system to get some information, to like reload because you have like a printf somewhere or whatever system out, Erlang. Like I had to do that, and it's so disruptive because you got to take the system down.
Right.
And Erlang, you don't.
So yeah, I could probably pick something that's my second favorite, but it's like way lower down the list. Like it's in the noise compared to this. I mean, that's just my own personal opinion. But all right, anybody else?
Whenever you start unifying functions, for example, without the per
it's easy to load that code onto other nodes.
It's iterating over each node.
Yeah.
Okay.
There's a built-in function just called node load that will load that code on all the other nodes as well. That can be a little bit dangerous, so you have to be careful. Like most of the time, you would actually want to go load the code on each node individually, so it's actually sitting there on the file system. So if it gets restarted, it picks up the new code. Whereas if you just send that new module over distributed Erlang, if that node gets restarted, it's going to pick up the old code again. So you have to be careful, but you totally can load a brand new module on all 100 of your nodes with one command, which is pretty cool.
Okay.
But yeah, with a lot of power like that, there's going to be some gotchas.
Yeah, you're saying like you load it on one node, and then the other nodes that are based off the same as that node you load on, so whenever they restart, I don't pick up the.
They don't even have to restart. It just sends that code over to them, and there's a couple of gotchas here, but for the most part, whenever that module and function gets invoked again, it picks up the new code.
Who's setting that? That's Revo?
No, this is just an Erlang thing.
So load was called?
Node load, I think. NL.
So that's part of like LTP.
Yes. It's a little tough to distinguish what's OTP and what's like Erlang standard library, so I don't know offhand which it is. But yeah, you can send code that's on one machine to all the nodes that are connected and have it update on all of them. But again, that's probably not like the idiomatic way to do it. It's certainly the really convenient way, but there's some downsides as well.
If you wanted to test a fix, for example, you do that, it fixes it, you verify it, and then the actual deployment is file system based.
That would certainly be a reasonable thing.
Rails.
Yeah. And a lot of times what we'll do too is instead of loading it on all the nodes, we'll just load it on one first, see if it works. It's really easy to revert back. And if it works, then we'll go load it on all the nodes. Our system is a little different too because React is a replicated database. It's not that big of a deal for us to take a node down and do a roll and restart. And so if you have 10 nodes, you can take one down one at a time. That's not a big deal. So the hot code reloading is not quite as appealing for us since it's not that big a deal to take a node down one at a time. So that's usually the way that we will load code because of a few of the gotchas that I mentioned before. So like, depending on how you call a function, it may or may not pick up the new code as it gets loaded. So if I just call foo like this, and I load new code onto the system, it won't get picked up. But if I prefix it with the module name, which you don't have to do if you're in the same module as the function that you're calling, then it will get picked up. So if you have some tail recursive function, then you could be potentially stuck on that old code and not realize it. So there's a few gotchas like that, and unless you have a real strong command of those gotchas, I would advocate not kind of doing that unless you've really convinced yourself it's the best thing to do. Yeah.
So you recommend making the full explicit path to the module call and function name right not everywhere?
No. I'm saying I don't recommend using hot code reloading unless you're really aware of all the consequences. It's a really cool feature, but because there are some gotchas like that, you should be aware of them and know kind of on your own module level where it's going to make sense to support hot code reloading. It's even more subtle than that too, right? It's on a per process basis as well. So if I just go kill all the processes, even if they're running with foo like that, and then a new process starts, a new process is going to pick up the new code. So you don't have to go crazy and prefix all your local modules like that or anything like that. You just have to know that within the life cycle of a single process, it's not going to pick up that new code for local modules. All right, well, thank you.
Thanks. So to Reid's point about it being like the favorite feature, I think like of all the features of Erlang that you can argue, Erlang is suited for certain applications. It's like this one, like to a manager, to some decision maker, saying, everyone has bugs. Like you put something in production, it's going to have bugs. What is the cost of debugging that? What is the cost of fixing it? In every other system, the cost is probably order of magnitude higher. That's a very straightforward argument. You can make that at a very technical level. I think these features actually make this cheaper to run, and that's true. I think there's probably a handful of people, 3 or 4 people here who are responsible for Todd's code. So he's responsible for a system that's been written. It was written a long time ago by someone else, and where's Todd literally? So like that's a material difference from a management standpoint. Like you invest in something over a period of time, the dollar values are less for something that you can fix cheaper, more quickly. Just simple. So, like to throw that out there for people who are. It's fun to work with Erlang. It's hard to get Erlang into your environment because it's kind of weird. But this is a very powerful argument for like this is why this makes sense. One of I think probably 3. So that's my religion. So with that. Just going to be talking about some gotchas, and I don't know what all the specifics are, but I know that there are a lot of gotchas and everything, so this should be interesting.
Feel free to shout out if I miss them.
Are you using